Hello everyone. We're going to learn sections 10D and E in this lesson. So in section 10D, we will be looking at how we can find the area of a triangle if we have an SAS side angle side triangle. If you take a look at triangle ABC in this diagram, side A, side B, and angle C are given. If I draw the height of the triangle extending from vertex A and call this the height of the triangle, how can I relate the height h to side B, the hypotenuse of your right triangle, and also angle C? Well, here we have the opposite side h, hypotenuse B, therefore h over B is sine C, or we can say that the height of this triangle is B sine C. And because the area of a triangle is half base times height, using substitution, you have half times the base, which is A, and the height of the triangle, which is B sine C. And this way, you can use this formula to find the area of an SAS triangle. If you apply this pattern, the area of this triangle can also be found using half side B times side C sine of A, so that will be this height, or half AC sine B, which means that C sine B would give you the other height of this triangle. So applying this formula in this example, find the exact area of triangle ABC. Well, here we have side C equals to 9 units long, side A is 10 units long, and then the angle 45 degrees is given. So using the angle 45 degrees, we have chosen to draw the height of the triangle extending from vertex A, which means that the area of this triangle will be half A times C sine of 45 degrees. Substituting the numbers into this equation, you can simplify this by multiplying 10 and 9 and a half. That gives you 45. And we know that the exact value of sine 45 is 1 over root 2. So if you multiply this and rationalize the denominator, this will give you the exact value of the area of this triangle as 45 square root 2 over 2 square units. And now let's turn to the next page and take a look at a more extensive example. In example 2, you have a cuboid, which is like a rectangular prism, had sides length of 5 centimeters, so that's the height, 9 centimeters, that's the depth, and 20 centimeters, that's the length. This diagram shows the diagonals of 3 of the faces, so side AB, side AC, and also diagonal BC. So first you are asked to find the lengths of AB, BC, and CA. Well, because these are just diagonals of a rectangular face, and you know the dimensions of each rectangular face, you can actually use Pythagorean theorem. For example, if you're looking for the diagonal AB, you'll be looking at this right triangle with dimensions 5 and 20 and AB. Using Pythagorean theorem, 20 squared plus 5 squared square root, this will give you 5 square root of 17. And then if you want to look for the length of CA, which is the diagonal on the right side here, well, you can again use Pythagorean theorem, because you know that the base of this triangle is 9 units long, and you know that the height of this triangle is 5 units long, and the diagonal is the hypotenuse. So CA is 9 squared plus 5 squared, square root, 81 plus 25. That will give you 106 square root. And last but not least, you also have diagonal BC. So this time you will be using 20 and 9 as the two legs of your right triangle. You will end up with the square root of 481. Part B of this example asks you to calculate the size of the angle A, C, and B. So if you follow the diagram, A, C, and B is right here. So the turquoise color, this angle, is what we're looking for. And you can see that there is this red triangle is kind of floating in midair. Since we know that AC, BC, and BA, we just calculated the length of these diagonals. This is an SSS triangle, and so this allows us to use the cosine law to relate the three sides and also angle C. So to calculate angle ACB, you will use AB squared as the isolated side in cosine law, and the rest follows like this, substituting all of the known given information or calculated information. Wait a sec, this is not working. There we go. Wait. So substituting all the values, rearrange the equations properly, you will get angle ACB equals to 69 degrees. So you can see that this is just a straightforward application of the cosine law. Question C. You are going to calculate the area of the triangle A, B, and C. So now you can see why we need to do part A and part B in this question. In order to calculate the area of triangle ABC, we can use the angle C and look at the two sides. So AC and BC, that gives us the SAS triangle. And then we can use this information and apply the formula you just learned today. So the area would be half AB sine C. Substitute these lengths that applies to the dimensions of this triangle, sub in the numbers, you will end up with 105 square centimeters. And lastly, in question D, we are asked to find the length of AD. Well, where is AD? AD is the diagonal of the cuboid. This blue line appears here. And you can tell that you can actually use AD to form another useful right triangle. That includes the height of this triangle, which is 5 units, just like the height of this cuboid. We'll label this corner E. So now if I connect A and E, you can see that, well, the three blue sides actually form an upright right triangle. Well, how can I find the length of AE? Well, it is on the bottom face of this cuboid, so it's 20 squared plus 9 squared, square root. And then knowing that the height of DE is 5, you can actually piece these information together and say that while the square of AD, the hypotenuse of the blue triangle, is equal to the square of AE plus the square of ED. Well, side AE squared is a Pythagorean theorem on its own. So 20 squared plus 9 squared, and then ED squared is 5 squared. So as you can see, we don't really need the brackets here. Add all the square of these numbers, all the three sides of the cuboid, you end up with AD equaling square root of 506 centimeters. And in this part of this example, we have demonstrated that, well, in order to find the diagonal or the length of the diagonal of a cuboid, all you need are the three sides of the cuboid itself. You square the length, square the width, square the height, and then all square root. That will actually give you the length of the diagonal of cuboid. So that's the end of this lesson. You can go ahead and work on the following questions as homework or classwork. In your homework, there are some questions that talks about the side length of the sloping side of a pyramid. So when they refer to this, it is just one of the edges, the slanted edges on the pyramid. Okay, and that's it.